Suppose there are two buildings, building A and building B. Building A is little higher than building B. So if you are in the roof of building B while your friend is in the roof of building A and you are being watched by your friend like this, then the angle occurs or the angle generates is called the angle of depression. Simple. I am repeating again. You are in the roof of building B and your friend is in the roof of building A. Building A is higher than building B and you are being watched by your friend, and the angle occurs or the angle generates is called the angle of depression. So that means if any object in the lower view is seen by from any other top view from any person, the angle generates or the angle occurs is called the angle of depression. So here it is, if in the A point, if any object lies, and the object must be in the lower view from where the object is being seen, right? So here O is the point from where the object A is being seen. So then, like this, the angle occurs. The angle is AOB is called the angle of depression. In the opposite case, think about it, when instead of you are being seen by your friend, when you are directly watching your friend, in that way, when you are directly watching your friend, right? So that time, actually what you do, you are just watching in the higher position, in the top view, right? In the previous case, you are being seen from the top view when you are in the lower view, right? But in that scenario, yes, you are in the lower view, but you are watching the top view, right? So in that case, the angle occurs or the angle creates is called the angle of elevation. So that means when any object is in the top position, when it is being seen by any lower view, the angle occurs, so the generates is called the angle of elevation in that way. So here it is the same thing, the AOB is equals to the angle of elevation, because here is O is a point from where the object is being seen, and the object is, if is in the A position, so AOB is angle of elevation. In the problems of height and distance, right, sometimes you have to determine the height, sometimes you determine the distance, but the thing is, this is very easy. Suppose there is a right angle triangle here, right? It is a right angle triangle here like this. Is A, B, C. So here you can see the AB is nothing but the hypotenuse, and the BC is a height, and the AC is the base. So sometimes you have to, when the base is given to you and you have to find out the value of the hypotenuse, right? What you have to do, you just have to use the cos, because if the angle of elevation, right, if the angle of elevation or the angle of depression is equals to 30 degree, 45 degree, whatever it is, you have to use the term cos, because cos is equals to base by hypotenuse. So if you know the value of base, you can easily find out the hypotenuse. Or if the hypotenuse is given and the base, you have to determine the base, then the same thing is applicable. You have to derive from the cos. So in the relation of base and hypotenuse, or the hypotenuse and the base, whatever it is, you have to use cos. And the same thing if the height is given. Here in our case, the height is what? BC. If BC is given to you, suppose the height of a building, the height of the tower, right, is given to you, right, and you have to find out these hypotenuse. Hypotenuse, that means A, B. If you determine the hypotenuse A, B, then what you do? Suppose the ideal case is what? In the point B, there is a kite, right, and this is the height of the kite from the base is what is given, right, and you have to find out the length, find out the length of, what should I say, the length of the wire. Length of the wire is what? A, B. So then you have to use a sine, because sine is equals to height by hypotenuse. Or if the hypotenuse is given, then you have to find out the height, right? The same thing is applying for the tan, because if when the height is given, you have to find out the base, or the base is given, you have to find out the height, you have to use the tan, because the tan theta is equals to height by base. So in the case of base hypotenuse, you have to use cos. In the case of height and hypotenuse, you have to use sine, and in the case of height and base, you have to use tan. This is very simple. So think about it. Suppose here's a point P, and from the point P, the angle of elevation to the top of the tower is 30 degree, and you know the height of the tower is exactly 100 meter, and you have to find out the distance, right? You have to find out the distance to the point P, right, to point P to the base of the tower, right? That means if it is a P, if it is A, if it is a B, that means you have to find out the distance PB. How can you find out? And here this is given, that is the angle of elevation is what? Exactly 30 degree, and the height of the height of the building, height of the tower is what? 100. So what do you do? The height is given, you have to determine the base simply, because here the base is the distance between the tower, the foot of the tower to the point P, right? So what we need to do? There is a tan theta is equals to what? Height by base. Height is equals to what? Simply height is equals to AB, right? AB here 100, right? And also there is a PB. PB is what? PB is the base. Put PB. And now we know the value of tan 30 degree. Tan 30 degree is what? 1 by root 3. So 1 by root 3 is equals to 100 by PB. You have to find out the value of PB. So PB is equals to what? PB is equals to 100 into root 3. 3 is equals to 1.732. In the question, the value of root 3 is given sometimes, or you should know the value of root 3 is equals to 1.732. If you just put the value of root 3, that is 100 into 1.732, what we have? 173.20 meter. This is the distance between the point P and the foot of the tower, right? So this is a very, this kind of question will not come in your examination, but why I'm elaborating that is because one reason, that is to show you why and how to use this tan, sine and cos to the specific segment. An aircraft is flying at a constant height with a speed of 360 km per hour. From a point on the ground, the angle of elevation of the aircraft at an instant was observed to be 45 degree. After 20 seconds, the angle of elevation was observed to be 30 degree. Determine the height at which the aircraft is flying. You can use root over 3 is equals to 1.732. So the starting position of the aircraft is A, and after 20 seconds it would be B. So the aircraft is watched from the point O, right? So in the beginning, the angle of elevation is 45 degree, and after 20 seconds, the angle of elevation would be 30 degree. So if we draw a perpendicular from A, like AE, and from B, BF, so the angle AOE is equals to 45 degree and angle BOF is equals to 30 degree. So if we take the height at which the aircraft is flying is equals to h. So the distance covered by the aircraft, that is very important. So the distance covered by the aircraft is equals to AB, we can see here. So AB, so how to determine the distance? Distance is equals to speed into time. So the speed of the aircraft is what? 360 km per hour. And the time is what? Here 20 seconds. So we cannot directly multiply 360 to 20. So we have to convert 20 seconds to the hour. Because the 20, the parameter or the unit is in seconds. So we have to convert it to the hour. So 20 must be divided by 3600 to get the time in the parameter of hour. So what we have, the distance is equals to speed into time. So is equals to 360 into 20 by 3600. So is equals to 2 kilometers. So the distance between AB is equals to 2 kilometer. And now from angle, sorry, it's not angle, from the triangle AOE, we can say tan 45 degree is equals to h by OE. So why h? H is here the height of the triangle. There is AE, so height of the triangle by the base. So base here is OE. So we generally can say OE is equals to h because tan 45 is equals to 1. And now from angle BOF, we can say tan 30 degree is equals to h by OF. Here it is the same, height by base. So tan 30 is equals to 1 by root 3 is equals to h by OF. So here OF is equals to root 3 by h. Now we need the equation. So we already know that is a EF. Here EF is equals to AB. We simply can determine from this, from the picture, from the diagram, that is EF is exactly equals to AB. So AB is equals to 2 kilometers. So that means EF must be 2 kilometers. So here EF is equals to 2. That the EF can be written in the form of OF minus OE. Think about it. OF minus OE is equals to exactly EF. So OF minus OE is equals to 2. We already have the value of OF and also OE. So OF is equals to root over 3 into h and the OE is equals to h. So that means root over 3 into h minus h is equals to 2. So h into root over 3 minus 1 is equals to 2. So now we have to determine the value of what? Our intention is to just find out the value of h, that means the height, right? So h is equals to 2 by root over 3 minus 1. So you already know, we have learned in the previous lesson and the previous module that how to determine that kind of value. So it is equals to 2 by root over 3 minus 1 into root over 3 plus 1 by root over 3 plus 1. So what we have, 2 into the value of root over 3 is equals to 1.732 plus 1 by 3 minus 1. So the answer is 2.732 kilometer. So that means the height at which the aircraft is flying is equals to 2.732 kilometer.